Hello, and welcome to AI 42. Hello, Gosa
Hello.
and Goran.
Hello in
Hello.
2022.
How are you? I'm
All
really,
good.
really excited today because this is our first session for 2022, and then it feels extra special to be able to say hello again to one of our previous speakers here, to Goran. You
Yes.
were
Thank you.
part of the real-life machine learning conference that we had a little bit earlier last year in September, I think.
Yeah, something like that. I'm also not sure. Was it September or October? But was really nice sessions over there. Was really good fun.
Mm-hmm. Mm-hmm.
Yes, so Goran, can you say a little bit about yourself once again? Because you're working in Pandora, you're AI MVP, but can you just say anything more about yourself?
Yeah, sure. My story originally from Croatia, moved to Denmark some 7 years ago, then 2.5 years ago moved to Malmo, Sweden, where I live now. And just recently I joined Pandora as engineering manager to lead the team, data infrastructure team. And yeah, I'm Microsoft AI MVP. That recognition usually comes for being active in a community, doing a lot of those sessions, workshops, and so on. So you can, often see me on some meetups and conferences. Nowadays, more online than in person, but hopefully, we've seen some in-person conferences. So hopefully, after the winter, the trend continues and world goes a bit more back to normal. At least I would like it to go to some conferences and meet people in person, to shake some hands. Yeah.
Oh yeah, it's much different to meet people face to face than everything online.
Yeah, that's true.
Yeah, and I follow you on LinkedIn, and time to time you just post a lot of things about IoT, drones, and other stuff, and it's really exciting.
Thanks. Well, yeah, I'm a I'm a tech guy, and I like to explore what technology can do. And yeah, I often share this knowledge. So yeah, that's me.
Yeah, so if you would like to know, just follow Goran on LinkedIn. There's really cool stuff he shared.
And we can also share the link to the previous session that Goran had with us in the chat afterwards here. But I think before we leave the stage to Goran, we're just gonna have a quick introduction here into AI 42.
Yeah.
So first I'm going to be describing a little bit here about the background here to why we've started the AI 42. So the thing here is that we also hear that there's really no good starting point that can take you sort of from A to Z to teach you about machine learning and AI from basics. So what we've done is we've created AI 42. So we're a strong team consisting of 3 Microsoft AI MVPs, me, Eve, and Gosha. And what we want to do, we want to provide you with a valuable series of lectures that will help you to jumpstart your career in data science and artificial intelligence. So we will provide you with the necessary knowledge so that you can land your own dream job, as long as it's related to the fields of data science and machine learning. And the concept is quite simple. So what we do is we've invited in professionals from all around the globe that will explain to you the underlying mathematics, the statistics, probability theory, and also data science and machine learning. And we will guide you through this all the way. So all you have to do is to follow our channel and enjoy this content that will stream to you every second week. And don't worry, we've all started here from scratch, and we're very happy to be able to help you to build up your knowledge. And you can always stop and rewind the videos or ask for clarifications in the comment section. So hope to be able to assist you on this journey, and that we will also like to have you as a guest in our show one day. And we've also created cross collaborations with other organizations. So we think that we will be able to give you the best opportunities so that you can broaden your own network in the AI and data science community. And also with this combination of our offered services, we would also like to support groups that are not so recognized yet. So that said, we switch over a little bit here to this.
Yeah, so our organization is sponsored by Microsoft and MICE, and we are humbled by all this support we get from our contributors as well. Thank you for leaving background for all the beautiful graphics content, and me and Mary for the cool intro music before the event. We are the close collaboration with C# Corner and Global AI community, so our lectures are going to be available also on their YouTube channel, additionally to our own media. Nicole taught, create, and review all text content we use on our website, on Advertising, and during our session. You can follow us on Facebook, Instagram, and Twitter to become a part of growing community where we share knowledge and fun. You will find every information that will bring you on advanced level in the field of AI and data science. You can as well watch our record session on our YouTube channel and find our upcoming session on our Meetup page.
Yes, and we also have a code of conduct. So the code of conduct will outline the expectations that we have for participation in our community, as well as the steps you need to take for reporting unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly, be patient, be welcoming, and also be respectful with each other. And you can find our code of conduct here on this link. I think with that said, we can get back here to Goran.
Hello back, Goran. So can you tell us a little bit more about this session, because we are really excited to have it?
Yes, sure. So title of session is From 3D Model to AI on the Edge. I will walk you through some, first of all, AI basics, and then show you some things that you're probably familiar with, some services in Azure, and then we will go into some examples and prepare build one model. I will show you how one model is built and tested on the edge. And through this story, like this line that connects all this is synthetic data for AI training. So hopefully you hear some new stuff and learn some new things through the session.
Yeah, thank you. So then we will leave the stage here to you, Goran.
Yes.
Okay, great. So I introduce myself, just quickly, over 15 years of experience IT, tech guy, did a lot of projects. My Twitter messages and LinkedIn messages are always open. Like if you work on some interesting projects, want to connect, yeah, just feel free to reach out and let me know what you work on. As I said, this session starts with some basics. So we will talk a bit about computer vision, and by its definition, it is a scientific field that deals with how computers can gain high-level understanding for digital images or videos, right? So teaching our computers to be able to see and to interpret these images. And most common tasks that we have in this field are image classification, object detection, optical character recognition, facial recognition, pose estimation, and so on. So those are some most common ones that you will see. Maybe some of them you already used. And as I said, we will slowly build through some of these examples. And what this session is about, it is about object detection. And if you have picture like this, if you run it through some object detection model, you would probably get some result like showing, okay, those are the classes over here. Probably some standard models out there would show you also, okay, this is a dog, that is computer behind it, even though it's blurred out, it would probably recognize it, and so on. So with object detection, idea is that we recognize and detect specific object in the picture to get information where exactly in the picture it's placed, so we get some coordinates and width and height of this box, so being able to tell, okay, here it is. And if you want to achieve this, you probably so far seen or most likely tried out the Azure Custom Vision. It's nice little service. You can access it via customvision.ai, and over there you can easily create models. And I will quickly walk you through one simple example. So let's imagine that we want to find this Lego minifigure Chewbacca. Here on the left, where is it placed on the board, right? We cannot use the standard models for that, because this Lego minifigure was probably not seen by the standard model so far. That model was not trained with images of the Chewbacca. So we want to create our own model being able to recognize it and to find it among the all other Lego minifigures on this board, similar to that game Where's Waldo, right? So if you go to Custom Vision, over there you can create new project. You give it some name, you can write the description, define the resource and resource group, and you can choose the project type. We have classification and object detection. We said we are focusing on object detection in this session, figuring out like where this object is exactly in the picture. And classification would tell you information like, for example, is it cat or dog in this picture? Like most represented object in the picture is identified, and you get answer back like, okay, is it this type of object or that type? And for this project, how it works, how Custom Vision works, what we need to do is we need first to upload images that will be used for model training. We need to tag them. That means we will select where on those images exactly is object placed. We will train the model, and then we will test it out. So if we go with this Chewbacca, we take some pictures. Over here you can see 17 images will be added to the project. This minifigure is placed on the Lego catalog just to have some variations in the background, right? And you upload those files, and then you tag where in this picture is exactly Lego minifigure, and you give it some tag to to that part of the picture. So Chewbacca is placed here. You click around, go each picture, you set this up. This tool has also some smart recognizer, like where the objects are, so it will help you out while you doing that. You can try it out. When you tag all the pictures, you train the model, and now you can, with the interface, you can do the quick test here, or you can publish this model and test it via the API, which means you will send some picture and you will get results back. Minimum number of pictures required for object detection model training is 15, and that is really, really low. Like if you want to achieve some kind of accuracy, you need a lot of pictures. Like 15 is super low. So first time this model was trained and I made the test, you can see over here there are some detections happen with some probability really low, like 20%, but those are not Chewbacca's, right? That's not Chewie. We are getting some results, but obviously this is not good enough. We need much more pictures for AI to be able to understand, okay, that object is placed over here. So in order to do that, like we can go back and upload more images, tag those additional images, train the model again, and then test it again to see, repeat this whole process to see how it works. After adding a few batches of images over here, you can see that I have iteration number 3. So I added images 2 more times to be able to detect, okay, Chewbacca is over here, and I got accuracy of 40.8%. That is still pretty low, but you got the idea. Like adding more and more pictures, like you'll be able to train it better and to identify this object correctly. And as I figured out, this is complicated stuff for AI. Like it really needs a lot of images. Those minifigures, even though they look different, they are really similar and hard to recognize. Okay, this is what we are looking for, and this is something else. So repeating this process, like there is one thing that will probably come to your mind, that most of the time you are spending over here uploading and training, uploading and tagging images in order to train the model, which runs automatically. You get the model trained in a few minutes, and of course, being able to test is just one click away for full tests, similar to publishing the model and trying it out. So usually taking images, you will do it with the camera. You need to upload it to your computer, upload it to cloud, to custom vision, each tag each one of them, and then run this process over and over again. So over here is really time consuming, and maybe some things through this session will give you the idea how this can be improved if you are doing the custom vision. And what I have in mind, like I mentioned in the start, the thread that is connecting all this is actually synthetic data. And synthetic data can be generated from different computer simulations or algorithms, and it is alternative to real-world data that can be used to train AI models. Like, why would we use some generated data to train AI models? Well, it will shorten the time for data collection and tagging. So we can make it in a way that it shortens this time. It will minimize costs for data collection. Imagine that you work for some company that needs to recognize some product that that you have, and now your boss gives you a task to recognize it with 98% of accuracy, and then you spend weeks and weeks taking pictures and tagging them, right? You can also reduce the bias in your training data. And also you could simulate different environments and such. Let's imagine that you are your company is producing cars and you want to recognize that specific car model. So you can take a lot of pictures in your warehouse, but maybe you want to recognize it later on out there in forest. So how to give AI some pictures from there to have a better accuracy. And all is about getting more accurate AI detections. And this synthetic data, this is not something I came up with. This is a really hot topic out there, and if you try to search a bit, like, you will find a lot of mentions of it. And this is Gartner research some time ago, I think 2 years ago, published or something. So over here you can see that over time, until 2030, use of synthetic data will be much more than real data. And with real data, we also have a lot of those problems like GDPR, this and that. And with synthetic data, we are able to generate a lot of data that's easily used for models to be trained. This real data will not disappear. We will always need it, but as addition to real data, like synthetic data can really be is really a great thing. And you can even train models just on synthetic data. So what solutions are there to generate the synthetic data? One of them is Unity Perception. And Unity mostly focus, as far as I figured this out, for like B2B model, working with different companies and such, but they do offer you a package that you can download, install in Unity, and try it out. So you can, for example, import different type of products that you have 3D models. And nowadays it's really common that any kind of industry we talk about, there is first 3D model of the thing that we are producing, right? So it's it's easy to get that. And combining these 3D models, and maybe you recognize this scene if you use the Unity, otherwise you'll see it soon. As a quick demo, it works like one 3D environment where you have your camera, you place some objects that you can tag each one of them, and then you generate different backgrounds behind in order to get the pictures as a result for this data training. So when you move the camera, you get the pictures from different angles, store those pictures, and use them for the model training. That's what Unity Perception is giving to you as an option. We have some viewers from C# Corner. Hello to them. It's Unity is one of the things you should definitely try out if you know C#, because it's a great tool. It's free to try out. There are paid models if you want to get rid of logos when publishing and so on. You can read more about that, but it's really interesting because in Unity you have this 3D world where you can place different objects, and with programming you can focus on the game interactions and such, not doing everything from the scratch. So over here on the screen you see I have one virtual space, and I can create some 3D objects. Okay, here's some cube, right? I just made the cube. I can add physics to that cube, so it has gravity, will fall down, will hit something, detect collisions, and so on. Really interesting thing to try out. There is also an asset store where you can find a lot of 3D models and use that models in your game. Some are free, some are paid. You can check that out. But what I want to show you over here in Unity, I have one scene that is like realistic, some kind of realistic environment, industry environment. And over here I have a sorry, I have a 3D model of the forklift, and what I would like to do, like idea, I want to detect this. Why? Because the standard models will probably not detect that, and maybe my boss wants to know how many forklifts are driving around the warehouse. Maybe he wants to know different types of forklifts and such. And in case I have the model, I can easily place it on some scene. This is really drag and drop. And when I click play, I go into this. I have my camera placed over here. And click play. Then I see the game view where I actually see the 3D model, how it looks like. So this is some kind of warehouse. This is a forklift and looks pretty realistic. We could use this for AI model training, right? If we put more effort in 3D design and such, we could make really nice, realistic environments. There is one great demo of Unity Office that you can, for example, check out. So this could be one picture for the training, right? And this loader at the moment over here, we could even rotate. Now I rotated 90 degrees, so you can see over here how it looks like. Idea is not to manually rotate everything and take a lot of pictures. That's why the Unity that's what Unity package is about. But since we got C# people watching, like, I wanted to show quickly how actually you write the scripts. At the moment I have two scripts over here, so I'll switch to Visual Studio Code. And this is how scripts look like in Unity. You have one class, and inside of that class you have the start function and update. Start called when before the first frame update. So when your scene is loaded, start is called. And update is called once per frame. So in this update, I define one new vector with 1 degree on y-axis. So this is my new vector, and I apply that vector to the current object I'll attach script to. So that object will rotate based on this vector. So we'll rotate 1 degree per frame. If I go back into Unity environment and attach this forklift script to fork loader, over here, object, you can see it is attached. I say play. And now our forklift is spinning, right? And taking a lot of pictures, now we can detect it from all possible angles. We could also change the backgrounds, or we could, for example, use this scene from different angles. So I have one camera script also. And in that camera script, I define target, like a game object that is target, and define one point. That point is position of the target, and camera will look at that point. In update, I rotate around that point, same way I rotate the forklift, so I rotate with 1 degree. If I go back here, attach the camera to the camera, and in the script I say that the target is, let's find it, fork loader, And if I click play, everything is spinning. Camera is slowly spinning around the forklift, and forklift is spinning around itself. This way, with few lines of code and with few realistic 3D models, we could generate a lot of pictures, right? And just using one scene. Now imagine all the combinations like changing different scenes, changing backgrounds, changing lighting, and so on. All this is possible. And basically not to do this manually and to take some pictures, that's what Unity Perception is about. It helps you out with that, to generate this and to train your models. So it generates the synthetic data for you. Unity is not only one out there working on such solutions. NVIDIA Omniverse Replicator, that is a simulation framework, and produce like this really physically accurate data. They made it in 2 versions. Like one is focused on vehicles, and the other one is focused on training robots. There is recently, I think some 3 weeks ago, I've seen some demo from their side, like more developer-oriented demo published out there, where you can check it out and try it out how it works. Yeah, so synthetic data can be generated with anything, and just like for this presentation, I decided to use the most used programming language in the world. You can guess, probably is the JavaScript. It is programming language, just to make some slide with the bold statement out there. And my take on it is usually, if we can do it with JavaScript, then we can basically do it with any other language. It's so simple, because if we can do it on web, then should be simple to use any other languages. So how we do it with JavaScript? There is one nice JavaScript library called Tree.js, and it allows you, based on WebGL, to show your 3D models in the browser, and that is really cool and nice. I'll switch over here to show you some examples. This is treejs.org. Over here you have documentation how to install it locally, run npm, and so on. And you can see now we are in the browser, and over here you can see I'm spinning the 3D model, and that 3D model is also animated. So things are moving over here. And there is a lot of different examples there. They are showing here, like how it works with different effects, transformations, like lightnings and things like that. So everything this is possible to do in your browser, which is, I think, pretty amazing and really nice library to have fun with. I will try to find, just a second, some examples like this one, where you can see one helmet. There's a lot of lightning reflections on it, and this really looks real, right? So if we can have this real representation, 3D object that looks like a real one, then we can generate images out of it. Okay, so how we do that with Tree.js? Just a second. I'll show you example. So over here, I will run it locally on my computer. And what I have over here is model of R2D2, Lego R2D2, and that's what I have at home. I was like, when I got idea for this session, I was like, okay, what model could I use? Something that I can show easily in the presentation. So I found this little guy, and I was like, yeah, that would be fun. Maybe I can find 3D model on internet, and there's so many 3D models marketplaces. You can find a lot of stuff. So this is a 3D model of the R2D2 used by with help of 3JS. We are displaying it in the browser. So let's take a quick look at code. It is HTML page. We have a head and body, import some stuff that are needed, define some variables over here, and just a second, try to stretch this a bit. And in this function init, we define some standard stuff. So first we need to define the container. We need to define the camera and our scene. So that camera is looking at this scene. We define the lights in the scene. This is a standard code that you get when you open the example how to display the 3D model. So I'm not going much into that. We have ground and we have ground grid. If we take a look at the example here, right, we have, I can even move it around. We have a ground, this white thing, and there is a grid on top of the ground. And on top is placed our model. And as I said, model is placed there. It's FBX model. And for that model, at the moment, it is just white because we haven't applied the textures to it. And that model is added to the scene. We rendered the scene and we added the controls. Okay, so let's do some cool stuff. First, let's add textures to the model. I will uncomment these lines, and those are just definitions. Textures are the PNG files, right? Model consists of two parts. One is the head and the other is body. For head and body, we need this texture. Now I saved, refresh over here, and yeah, we have our R2D2 that looks pretty much realistic compared to this one that I have over here. Okay, so I would like to do something else. I want to create some custom background, not to train it just on the white background. So I can, for example, enable this setting the background texture. But before that, I need to disable this ground and grid that was added by default. So I'll just comment these things out. No ground, please. No grid. And for background, I am using the Star Wars backgrounds. You can Google that and find a lot of those official wallpapers. So I will use one of those wallpapers as the background here. I save, I refresh, and yeah, we have our model in some realistic environment. Right now I'm using mouse to turn it around. And what else we can do? We have one function like what's happening on the window resize, and we have function animate. Those are the standard stuff. But what we have custom over here is we can add one to animate the camera, right? And there is some calculation how to move the camera around. If I save that and refresh over here, now I'm not moving anything with the mouse. Camera is automatically moving around. So based on this, we could generate a lot of pictures and train our model, not just to rotate the camera around. We can change different backgrounds, and each time we are taking a screenshot, take take it with different background. And it's cool because we can also rotate this object in many different directions and detect it also from the bottom and top and so on, which is sometimes not easy with the real 3D objects. Okay, so we have our R2D2 flying around, and we want to take pictures of this. So how can we do that? Solution is Playwright, and it is a small framework made by Microsoft. It is used for the testing and allows like this, works cross-browser, cross-platform, cross-language, allows you to test mobile web and so on. Really nice thing if you want to test your web pages. There is a lot of options it supports. Really great thing. I leave it to you to explore. But for our case over here, just a second, we have one small script where we will run the test, and that test will load our current page, and we'll save the screenshot of it. Then it will wait for 3 seconds and take another screenshot. So basically we are taking screenshots of this R2D2 as it is spinning around. Of course, we could also had to change the backgrounds. We could add options to change lighting and so on. How this works, how we run it, basically from the command prompt, we will run this Playwright test, and it will execute now, take a screenshot, run for 3 more seconds, take another screenshot, and store it locally. So if I take a look at the folder I have over here, you can see there is a screenshot generated. Something went wrong here, but okay, this one is fine. Maybe if I run it again and put a bit of pause on the beginning, it would work better, but that's can happen. Okay, so this way we can generate a lot of screenshots and use them for AI model training. And if I go back to my presentation slides, this is what I did with the R2D2, changing different backgrounds and spinning the model around, right? So I generated 100 images. All this is synthetic data, so the model never seen a real object, and trained that model to be able to recognize it. And how you can test this model, like I said, quick test over here, or you could publish it and use our API, but you could also test it on the edge. And what that means, in many scenarios nowadays, like we need this intelligence at the edge. Just imagine one self-driving car. It has so many different sensors in it. Like there are different sources on internet I try to find, but somewhere around 20 terabytes of data is what car produce in 1 hour or something like that. You'll get different numbers, but it's huge amount of data. And now just imagine pipeline that you need to upload this data to the cloud. And that's not the only example. That's why AI is moving more and more to the edge on different devices, capable to execute the model, recognize something visually, and only upload data points to the cloud. So only recognized points go to the cloud. And last year, Microsoft released Azure Percept. That was in March, if I remember correctly. It is a this, as they call it, family of hardware, software, and services designed to accelerate business transformation using IoT and AI at the edge. You can find more info on the website. Their development kit looks like this. It consists of one smart board. In this nice case that is cooler, you connect the smart camera to it, or this is audio. There is a microphone linear array over here. There are four microphones, so you can use some voice recognition also on the device. In the cloud, you can log into your portal and search there for Percep Studio. You can see how it looks. It's pretty simple. I'll show you soon. So idea with Percep Studio is one service where you are able to select models that you want to publish to your device. You execute them and you get the results, like while device is detecting, it's sending those results to IoT Hub. From IoT Hub, for example, you can use Stream Analytics and connect it elsewhere, store the data, go directly into Power BI, and so on. So what you can do over there out of the box is you can use some predefined vision models, like this general object detection, people detection, like detecting products on shelves, or vehicle detection. That is for vision. And there are some voice assistant templates for, we said, like you can use this device's voice assistant and try out, like in hospitality, care, inventory, automotive, some templates how it could work. I believe all of you use some kind of voice assistant so far, so you get the idea. But we want to test our model, so we go into the Percep Studio. Interface is pretty simple over there. Like it will guide you nicely. Like, are you new to AI models? Do you want to create prototype, try out sample applications, or you want to do some advanced stuff? Over here on the left, you have option for devices. You can click that, select your device, and deploy model to device. And that's what I did with the model that was trained on R2D2 data. So I published it on the Percep and tried it out. And with only 100 pictures, synthetic data pictures, it was able to detect R2D2 around, as you can see, it's bumping between 69-70%. And this is also not the perfect lighting that I have over here in a video. And I think this is really cool because yeah, you don't need to spend a lot of time like taking pictures from different angle, uploading those pictures, and so on. Like all this can be generated automatically. So that was our test, and something I work on like since end of last year, somewhere since start of December, in my free time. It's called Synthetic AI Data, and it's my free time project that I applied for Microsoft for Startups. It got accepted over there, and the idea with it is exactly this: to generate synthetic data, because I think we need one, we developers need one easy to use web-based tool where you can go in, upload model, and generate this data. What Microsoft for Startups, just to go back to this slide, Microsoft for Startup is offering support with Azure credits. So if you have some idea or already work on some projects, feel free to submit it over there and see can they help you out? It's not only Azure credits, there are different licenses and things. You can find a lot of info on their website. This is a short preview how it will look like. So web-based dashboard where you can see those models, you can upload model and so on. And basically how it works is exactly that. You upload your model, you configure some options. I want this type of background. I want different lightnings. I want this and that, right? There are several options you can configure, and you push the button generate and you get the package of images. Yeah, in this configure option you choose, do you want 100, 500,000, whatever images, and you download them and you can use them for model training. It should also integrate because the custom vision has API where images can be uploaded. I hopefully will sort that out so that can be uploaded there. So basically, if you remember those 4 steps from beginning, it should be much faster to do it. If you are interested in a project, please follow on LinkedIn. I will be happy about it. So I promise I don't spam. There is some announcements like every 2 weeks approximately what I achieved to do and where it is. Soon I will publish some demo video. As a last slide over here, first of all, thank you for listening the session. I hope you learned something. And from share list, I got this Azure Hero learner badge to share with you. If you want to claim your badge, you can scan this QR code and add it to your wallet. More info about Azure Hero program can be found on this link over here, but I believe that you are already familiar with it and seen those digital badges all over. So once again, thanks for listening. I hope you learned something new and that it was interesting. And basically, idea of the whole session is to show how it's easy to generate this synthetic data. And I believe we'll be hearing more and more about synthetic data, especially for the vision training. Thank you.
Oh, this was really great. I really enjoy all the session you show. It was really amazing.
Thank you.
This is really a game changer, because I think this is one of the things that takes a lot of time if you're going to do object detection, to actually take these photos with different backgrounds and from different angles, and to be able to automate this is a true game changer.
Yeah, it is. I just remember my last project when I used custom vision, when I done a lot of photos and needed to go and from different angle. And now with this, what you show, it could be so quick and you don't need to this effort of making a photos and upload them.
Yeah, with use of those realistic 3D models, it's pretty simple. And like I said, this little guy was recognized just by using 100 pictures. Like in some visual detection, it's really not much. Like being able to teach computer to see, okay, this is R2D2, right? So
yeah.
that's a nice thing. Yeah.
So we have some questions here from the audience. Yep. So you can start with this question from Cloud Talk with Johnny Chips, who says, could you use LiDAR or camera technology to model the real world so that you can take imagery from the real world into Unity to use in this manner to automate AI model training? And have you come across any examples?
Yeah. I think this would be a lot complicated. Not sure can you really generate the 3D model, but we invented 3D scanners. I think that's much easier to use, to create 3D object first and then put it into Unity. With LiDAR technology, I'm not sure. Can you generate 3D object out of? I know that you get the point cloud, so maybe representing this cloud if it's high enough resolution, but this is really I'm not sure you would be able to do it, but maybe it's better to use some 3D scanner or that's something I would go after. But working, like I mentioned earlier, working in many different industries, there are 3D models already, and I was also like, when I got the idea for this session, I was like, okay, what I'm going to try out, and had those Legos around, as I usually use those for my session and stuff. And I was like, yeah, maybe I can find like R2D2 minifigure, and I was able to find it in 5 minutes. Like there is so many different marketplaces for 3D models out there. So I hope I answered. Yeah.
And he also says that this is awesome to see, by the way.
Thank you.
And then Gosha, do you want to take the next question?
It was excellent presentation so far. If anyone got curious about the 3GS example, I would recommend also having a look at Babylon.js. The library is also open source, baked by Microsoft.
Yes, I've heard about it, and I think I've seen it, but I haven't tried it out, honestly. So yeah, this is not of course, not the only thing out there. Point of my presentation was, let's grab something, super simple, put it in a browser, because if it's in browser, it probably works everywhere. And let's get some data out of it.
Okay. And then we have a question here from Gabriel, who says, is this considered part of the new data-centric approach for AI development? How do you see this trend growing in 2022?
Well, synthetic data, like if you take a look at that Gartner research that I shared, synthetic data is growing, and like by 2030, it's expected to be used 3-4 times more than real data. In addition to improve the model accuracy, or to fix some. To fix the bias, and to add additional scenarios to where it can be seen, and it was also part of the Gartner's hype cycle published at the end of last year. You can also find synthetic data there, and if you take a look a bit at what NVIDIA is sharing about it, you'll find this mentioned a lot. Like also like Unity, there are some nice talks about it, and Daniel Lange, he has some nice sessions. You can check it out on YouTube, and to learn more about it. Unity is also interesting because they have their own I think they call it AI agents, which you can train like a small bots in game that are able to understand something and such. So they also work a lot toward this field. But the idea is, do we need big complicated tools? We can do it really simple. So pick what is easiest for you if you have need for to generate such data. Yeah.
Yes. Yeah, that's fantastic here. So I think that's it for the questions.
Thank you.
Yeah, people really enjoy your session, and it was really, really great about this all syntactic data and everything around this one. And it's good that you show 2 languages as well, C# and JavaScript.
Well, yeah, we had viewers from C# corner, so it was. I think it was important, right? Yeah.
Yeah, So with that, I think we thank you, Goran, for a fantastic session. But please stay on StreamYard while we're finish up the session here. So we have some more information here for our audience. So we'll be back in a short while. Yeah, so just some information here about our next sessions. So 2 weeks from now, on January 26th, we will have a presentation by Terry McCann, and he's also been here with us before. So it's a warm welcoming back to him. So he's going to be talking about graph-based processing in Apache Spark. And then 2 weeks after that, on February 9th, we have Henk Bollman, who will talk about how we can build an Azure ML pipeline. But the thing is, Gosia, we are also looking for speakers.
Yes, so we're looking for speakers for next sessions as well. So if you would like to speak on and meet us online, so you can submit your session on sessionize.com AI42 and just come and speak with us and show something really interesting about AI and data science.
Yes. So with that said, we would like to thank all of you, both from me, Gosia, and also Eve, who couldn't be here with us tonight. So with that said, I think we can finish this session here, and we hope to see you next in 2 weeks.
Yes, see you in next 2 weeks.